In this video, we'll talk about doing mathematical expressions in LaTeX. The math environments in LaTeX expect some different syntax compared to the regular text processing environments that we've been using to this point. Basically, you can write in math in 4 different ways: inline text, the equation environment, the equine array environment, and the array environment. We'll talk about each one of these. There's a lot of different symbols that you can make for mathematics in LaTeX, and we wouldn't be able to cover all of them in just a short video like this. But one thing you can do is to look at the Math tab in Technic Center's drop-down menus right here. This has lots of different options, such as Greek letters, constructs, various operators, set theory notation, functions, boundaries, and lots of other things. So I encourage you to go through this menu to look at some different symbols once you get the basics of mathematical expressions down. The easiest way to write in math mode is through inline text. So in the document we've been working on, I'm going to create a new section. And we'll do inline text first. To write in math mode in the text, you simply want to put whatever your mathematical expressions are in between the $sign. So for example, if I wanted to write the letter X but in math mode, I would just put an X in between the $signs. And notice that Technic Center turned that text green. Technic Center does that to help you remember to close your $signs when you need to. So if you see a bunch of text that you don't think should be in math mode that's green, you very likely have forgotten the ending or beginning $sign. So there's the letter X in math mode. Let's say I wanted to write X squared. I would do something like that. If I want to put something more than just a single character in the exponent, I want to put it inside curly braces. So this would tell LaTeX to write X to the 2 plus Y. You may also want to use subscripts. You do that with the underscore. Now, normally using the $sign notation to put math expressions in the text will try to cram that mathematical expression into the normal space of a text line. This may or may not be what you want to do. So let's just do an example of this. I'm going to type the command \sum. That's going to produce a big sigma, the summation operator. And just to show you some options with this, you can subscript it and superscript it. And I'm going to compile that. Here's what it looks like. And so notice it put the subscript on in that line and kept the n in that line rather than putting the subscript below the sigma and the n above it. So that's what I mean by it tries to cram it into the same space as a normal line. Well, let's say you didn't want that to happen. If you had the command \display style before that, now you're going to get a bigger sigma, and you're going to get the subscript below it and the superscript above it. Another way to do math in LaTeX is in the equation environment. As you're probably expecting, if it's an environment, we're going to have a begin and an end command. And just as an example, I've got some code that I prepared already that I'm going to type into it. A couple of things to notice about this code. First of all, I'm using the frac command, \frac, that stands for fraction, and fractions work in a very simple way in LaTeX. The first set of curly braces is what goes in the numerator. The second set of curly braces is what goes in the denominator. I've got the partial command just to show you what the partial derivative symbol looks like, and I've got some expressions similar to what we've seen before. Notice the \times command that produces a multiplication sign. Also, notice I've got \curly brace right here. That is what tells LaTeX to actually print out a curly brace. So this is not a curly brace as associated with a particular command. That's actually telling LaTeX to print out a curly brace. And then finally, notice I've got the label command right here. You may remember labels from when we were working with floats, where we labeled a figure as something, as we have here on line 113 in my file. Well, just like figures and tables, equations also get numbers in LaTeX, and so you can label a particular equation so that you can refer to it later in the text. So I'm going to compile that twice, and that allows the equation number to get set. And what we can see here is this is how LaTeX typeset that. Here's the equation that I typed, and here's the number. Now let's talk about the equine array environment. This is useful when we want to add mathematical expressions with multiple lines. I've got some code here that I've already typed in, and notice I've started it with begin equine array, begin EQN array, and end EQN array. I've also added a label, and the code here produces separate lines of mathematical expressions. Notice that it looks a little bit like the tabular environment. We've got some text here, then an ampersand, then an equal sign, another ampersand, and then some more text, and double backslash to end the line. And then a similar setup on this line. Again, I've got ampersands around the equal sign. What this is going to do is line up the equal signs when LaTeX compiles the code. And a few new mathematical expression commands to point out here. First of all, notice the \sqrt, that stands for square root, \pi, that's the Greek letter pi, \sigma, that's the Greek letter sigma. And also notice this command right here. I've got \left and then a square bracket, and then over here I have \right and a square bracket. That's going to draw square brackets, but the left and right make this command a little bit special because I have a fraction inside those square brackets. The left and right added on there is going to make those square brackets big enough to fit around that fraction. On the second line, I've got \int, that stands for integral, and notice I've got that subscripted with -infty, negative infinity, superscripted with x, and notice I've got \no number right here. That tells LaTeX that we don't want to produce an equation number on that line. So I'm going to give that a compile, and here's what we get. Here's the first line, here's the second line. Notice we only get the equation number on the first line. And finally, I'll show you the array environment. The array environment is useful when you need to create a matrix. You could also use it very similar to how we've used equine array right here. But here's some code that I've typed to create a very simple 3x3 matrix with the letters A through I. First line is I've typed backslash and then the open square bracket and then backslash left open square bracket. That starts the matrix and gives it a square bracket on the left side. Then I type begin array and I'm going to type CCC in the curly braces. Just like with the tabular environment, that provides 3 columns in this matrix, and we're going to center the text in each one. Then type in the content of the matrix, very similar to how we've used tabular. I'm just typing the letters A through I, and I'm separating them with ampersands. Then once we're done, type end array, backslash right, square bracket, and backslash square bracket. That produces this matrix right here. So that's just a brief start with the mathematical expressions in LaTeX. There are lots and lots of different. And as I mentioned at the beginning, in Technic Center there's the Math tab that will allow you to look up many different equations. You can just select them and it will get produced right in your document. Another option in searching for how to make mathematical symbols is the Detectify LaTeX symbol classifier. And this is a very useful online tool. In this box, you can simply draw some symbol that you're trying to create. So for example, I'm going to draw the summation operator. And on the right side here, Detectify produces several different commands that it thinks may be what I'm trying to produce. So here's the sum command, that was the first hit. There's also the uppercase sigma. Here's an epsilon. These are all different symbols that look something like what I drew. And so you may be able to use this if you know of a particular symbol you want to add, but you can't quite figure out how to add it into LaTeX.